All right, so to finish our discussion on three-dimensional objects, we're going to look at surface areas. Surface areas are really just the sum total of all the different surfaces, or the areas of all the different surfaces on the outside of that object. For example, with a cube, now a cube it's a rectangular solid, but a specific one with all three dimensions equaling each other. We'll call them all S for side, I guess, or square, I don't know. But anyway, the surface area then of this cube is going to be found by just simply adding up all the surfaces. Now there are 6 equal size surfaces. Each surface, each square, has an area of S squared, right? So the individual area is equal to S squared for each of the 6 sides. And so the overall surface area, which we're going to call SA, abbreviated for surface area, is going to be equal to 6 of those S squares, right? 6 S squares, because there's a top, bottom, left, right, front, back. Okay, that gives you all 6 surfaces for a square, and they're all squares, or for a cube, and they're all squares. Okay, now for a rectangular solid, it doesn't simplify as nicely because not all of the dimensions are the same. All right, you have a length, a width, a height. They could be different. They could be the same. We don't know. But the surface area is, again, the sum total of all the different surfaces. Now, there are 6 surfaces, but pairs of them have equal areas. And so if you look at the area of this vertical side on the right, the area here is the width times the height, right? It's the 2 dimensions of that side. This front side has an area equal to the length times the height. And the top and bottom have an area that is equal to the length times the width. Okay, and so that gives you 3 of the surfaces. Again, then you double it, right? The top is the same as the bottom, the right is the same as the left, the front is the same as the back. And so you add those up and then double it because you can add the second one. So the total surface area is going to be the length times height, well, double that, right? So 1 for the front, 1 for the back, that's 2 LHs, plus 2 of the tops, which is 2 LWs, plus 2 of the sides, right and the left, which is 2 WHs. And now the order of these doesn't really matter, it's just as long as you get 2 of each of those combinations, you'll have all 6 sides, okay? For the circular cylinder, we have something a little bit different. It's still the sum of all the surfaces, but one of those surfaces is a little bit weird, the vertical one. It's kind of like a paper towel roll, that one surface. Now, of course, we've got to include the 2 circles, on the one on the top and the one on the bottom. So for that one, we consider the circular area for the top and the bottom. That's going to be your pi r squared. Right, there's your base area of a circle. Now for the actual toilet paper roll surface there, you can kind of imagine kind of unrolling this thing. If I were to take this and unroll it out, that vertical surface ends up rolling out into a rectangle. And that surface there, we'll talk about that area in a moment. So it rolls out into a rectangle that happens to have a height equal, or a width, whatever, equal to the h. But then the length of it happens to be the circumference of the circle around. So if you roll out a circle, its length that it travels is 1 circumference. And so here, if you were to sort of cut this on one edge and just wrap it out, kind of like the label on a can of soup, you cut it and then take it off the can and roll it out, it's going to be a rectangle whose width is the height and whose length is the circumference of the base circle. So that circumference there, the length is equal to the circumference, which is 2 pi r, or pi d, whatever you want to use. So the area must be the product of the length and the width, which is 2 pi RH, right? And so when we find the total area, surface area for a cylinder, it's going to be, surface area, is going to be 2 of the circles, so it's 2 pi r squared, plus this rectangle, the vertical surface, which is 2 pi RH. Okay? So we have 2 pi r squared plus 2 pi RH. That will give you the surface area of the cylinder. Now we could put this into practice if we wanted to. Of course, for any of these, maybe I'll just go ahead and pop them in here. Let's go with blue as our color. Let's say your side for the cube was 5 inches, you have a little 5-inch cube. Then the surface area can be found quickly as 6 times 5 squared, or 6 times 25. 6 times 25 is 150, so that's 150 cubic inches. Okay. Oh, not cubic. What am I doing? Square inches. There we go. 150 square inches. Okay, so that would be all the surfaces added together would be equal to 150 square inches. Now, rectangular solid, here's an interesting application. If you were painting the inside of a room in your house, it's a rectangle in shape. Maybe you wouldn't paint the floor, but assuming you would for a moment, the amount of paint that you need is equal to the surface area of that rectangular solid, okay? And so right now, the room I'm in, I kind of roughly measured it. It's not exact, but I roughly measured it to be, it's about 15 feet by 10 feet by 9 foot tall. 9 foot tall ceilings roughly, and kind of estimating that. Might be 10, I think it's 9. Anyway, let's say those are my dimensions and I wanted to paint all 6 sides or surfaces in this room. Then the amount of paint I need can be calculated using the surface area of a rectangular solid, okay? So surface area is going to be 2 times the length times the height, 2 times 15 times the height is 9, plus 2 times the length times the width, which is 15 times 10, plus 2 times the width times the height, which is 10 times 9. So we've got to put all that together, multiply it out, and add those 3 terms. Not too bad. 2 times 15 is 30, 30 times 9 is 270. 2 times 15 is 30, 30 times 10 is 300. 2 times 9 is 18, times 10 is 180. And we add those 3 values together, and let's see, that's 570, 670, 750. 750 square feet. Okay, 750 square feet. Now, if I was buying, white paint, right? Walls are white. If I was buying white paint by the gallon, each gallon that you purchase has a coverage. It's usually measured in square feet. They'll also give you a square meter, I believe, but square feet is going to be useful there. And so you just pick up however many gallons it'll take to cover 750 square feet based upon what it says in the label. Maybe it says, if it says 400 square feet per gallon, you get at least 2 of them, right? Maybe you get a third one just in case you put it on too thick or something, but that would give you enough coverage. Or maybe you get 2 gallons plus a little pint or a quart in addition to that. Anyway, that gives you some idea how to calculate surface area for a rectangular solid. And of course, for the cylinder over here, let's say I had a can of soup or something, chicken noodle soup, I don't know. And let's say the can had a height of 4 inches maybe, and a radius of maybe 2 inches? Well, let's go 5 inches on the height. 5 inches on the height, a radius of 2 inches, that should work. And then we want to figure out how much aluminum, it takes to make up that can. And so to do that, you would calculate our surface area, which is going to be 2 pi times the radius squared, which would be 4, right? 2 squared is 4. And then 2 pi times the radius times the height, which is 2 times 5, right? And so that's 8 pi. If you can see that, yeah, that's still visible down there. 8 pi plus 4 times 5 is 20 pi. And 8 and 20 makes 28 pi. I don't know if you can see that. Hopefully you can see that. 28 pi anyway. Write that a little bit bigger. Now 28 pi, if I punch that in my calculator, just to get a decimal approximation, if I round it to the nearest square inch, which is pretty close, we're going to get 88 square inches there. So not of that rectangle, surface area for the whole thing, I'll just put it over here. Surface area is approximately 88, did I say? Yeah, square inches. Okay, so just by plugging that stuff in, again, you're basically adding together 2 circles, the area for 2 circles, plus this rectangle whose width is the height and whose length is the circumference of that circle.